the light-coloured moth blends in very well with that lichen and is not visible. And on the right-hand side you have the darkened, soot-covered tree trunk, and of course the light-coloured form is much more visible. And if you're a bird looking for a lunch, you're going to spot the light-coloured moth on the dark background, and you're going to eat it, so the dark one survives and the light one disappears. And there's a selection for the dark form over the light form, so you get a change in distribution, you get a change in frequency of the two different forms, which can be interpreted as a change in gene frequency driven by natural selection. But there's actually a bit more to the story than that. There's been a bit of controversy about the peppered moth, and there's been some evidence that's come forward suggesting that the results that were initially published back in the 1950s were not as well founded as was believed. And recently there's been a swing back in the other direction, but we're going to look at that briefly. But here's some problems for the peppered moth story, which shows it's a little bit more complicated than sometimes presented. Here we have a chart of Great Britain prepared in 1971, where you have the distribution of the different forms of moth. We have circles here. If you have an open circle, that means 100% of the moths are the light form. If you have a closed black circle, that means 100% are the darker form. And then you've got a pie chart effect, where you've got more or less the lighter area. That's basically showing you the distribution, proportion of the two forms in different parts of the country. And it works very nicely for Liverpool, where you've got pollution. The dark forms are the predominant form. But then you've got the distribution is actually rather strange, because you can find in some areas where there's no pollution, 80% of the moths are the dark form. So why are they there? Surely they'd all been eaten by the birds, so there'd be much less than 80%. So this is the first problem with the story. The light form persists even in polluted areas. But as I say, there's been some research done, and there's actually some work published in August 2007 by a gentleman called Magirus. I don't know how he pronounces his name, that's how I pronounce it. He's based in Cambridge University, and he was interested in this story, and he published some material that actually caused a lot of people to question the story and say, well, this is not actually as good evidence for evolution as we believed. And he said, well, I didn't really want to do that. I wanted to show that it was quite good evidence. So he's been repeating some experiments, and he spent 6 years between 2001 and 2006 doing capture and release experiments near Cambridge with the light and the dark form of the moth. And what he found was, actually, the story seems to be confirmed in that the more dark forms are eaten than the light forms, because contrary to what was said before, at one time there was some evidence suggesting that the moth didn't actually land on the tree trunks at all, so it wasn't actually visible to any birds, so they couldn't eat them, whereas in fact he's found that they do tend to land on the trunk as well as on the branches. So as far as that part of the story is concerned, it seems to be confirmed. So, and predation, in other words, being eaten by a bird, is a major cause of the decline of the dark form, because now in Cambridgeshire what's actually happening is the dark form is becoming less common and the light form is more common, rather than the original event, which was the pollution which caused the dark form to become common. So we seem to have a mechanism to explain natural selection in action causing a change in gene frequency. But it's not quite so simple, because the dark form still persists. So whatever happens, in most areas you still find dark moths. But overall, there is definitely a change in gene frequency, and natural selection does seem to be one of the factors that is driving this. So we have to conclude, yes, natural selection is doing something. Natural selection is a real effect that we can measure and we can understand. And natural selection does do something. Natural selection eliminates the unfit. If you're not fit to survive, you get eliminated in a natural world. When we talk about human beings, of course, we protect our weaker members so they don't get wiped out. But if you're a moth living on a tree, it's nature red in tooth and claw. Natural selection will eliminate the unfit. Only the strongest and the best adapted will survive, and we have no problem with that. But random mutations reduce fitness generally. Not always, but generally. And of course, natural selection, eliminating the unfit, will tend to stop changes. And the one thing about natural selection that's never actually been demonstrated, and this still stands, is natural selection has never been observed to produce new features. And we're going to come back to this later at the end. But what we can say positively about natural selection is natural selection can cause changes in gene frequency, and the peppered moth is probably quite a good example of that. Natural selection does cause survival of the fittest. That's a well-established concept that can be demonstrated with the evidence, and it probably causes speciation. And you can one species can be split off into two different species and diverge slightly in appearance, or just like the Galapagos finches. You started off with one species of finch on the island, and over the period of time we have now 14 different species, although we have to remember that actually a lot of these species do interbreed, so they're not true separate species. But yes, natural selection is a phenomenon that can be observed, and it's probably a very important principle of biology. But there's one thing it doesn't explain, and no biologist has been able to explain the arrival of the fittest. Natural selection explains the survival of the fittest, not the arrival of the fittest. And that is a problem which is actually recognized by biologists who aren't creationists, biologists who are in the mainstream of evolution. Quite a lot of them are now acknowledging that there is a problem. Natural selection is a powerful force, it can do quite a lot, but there are limits to what it can achieve, and it doesn't actually explain the arrival of novelty. So let's look at an example that Dawkins picks up on, natural selection and the eye. This again is a very well-known argument in creationist circles. It comes up time and time and again, and of course as the debate goes on, the evolutionists and creationists discuss the origin of the eye. Can evolution explain the origin of the eye? Now, somebody once said this: if it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successive slight modifications, my theory would absolutely break down. And that was Charles Darwin who said that. So he recognized the problem, and he recognized that the eye was one of the problems. And so that I don't get accused of quote mining, I will go on and complete the quotation, which is, Darwin concluded, but I find no such case. Darwin claimed that he has solved the problem, that actually natural selection could produce something as complex as an eye. Although if you read what he says, it's rather thin on actual hard evidence. It's kind of, yeah, if we imagine this and imagine that, maybe we can arrive at something as complicated as an eye. So we're now moving into the idea of irreducible complexity. And the question I want to address here, is the eye irreducibly complex? So a few definitions, and actually Richard Dawkins gives us a definition of irreducible complexity in his book. A functional unit is said to be irreducibly complex if the removal of one of its parts causes the whole to cease functioning. And that's quite a good definition. I don't have any problem with that. Then he goes on to say, this has been assumed to be self-evident for both eyes and wings, and then Richard Dawkins goes on to do a fairly good job of demolishing that argument. And I would agree with him, because actually, as far as I know, no creationist has claimed that the eye or a wing is irreducibly complex. They claim it's complex and it can't evolve, but nobody's actually said that it's irreducibly complex. So I actually think that Richard Dawkins is getting a little confused between irreducible complexity and complexity. And in fact, we're going to talk about that a bit later, because it's a very important point. But I want to just talk about the eye for a while, because the eye is a very interesting organ. The eye is rather complex. And this is the diagram of the eye that you would observe if you cut somebody open and had a look at their eye. And here is a diagram of the retina of the eye. And I'm not going to go through and point out all the various parts. All I want you to appreciate is, and I'm sure you do appreciate this is very complicated. So we have an organ which is sensitive to light. It's self-cleaning, it's got automatic protection system, it's got automatic exposure control, operates at high and low intensity, focuses with a multi-element lens, doesn't have any chromatic aberration. The complexity of the eye is absolutely amazing. We would like to have a camera as good as our eye to take pictures with. So the question is, can evolution explain this? Now, Darwin claimed to have solved the problem. Well, his claim is a bit hollow, because evolutionists are aware there's still a problem, and there's been modern efforts to explain the evolution of the eye. And two gentlemen by the name of Nielsen and Pelger in 1994 wrote a paper called A Pessimistic Estimate of the Time Required for an Eye to Evolve, to demonstrate that actually it's quite easy to evolve an eye. So they started off with an eye spot, which is basically a light-sensitive patch of cells which responds to light so that an organism can detect whether it's light or dark. And starting with an eye patch, they claimed that you could, by slow, gradual steps, just like Darwin suggested